Hello friends, I am going to discuss today conversion from NFA with epsilon move to DFA. Now NFA with epsilon moves if any finite automata contain a transitions or move with epsilon transitions. For the given example, there is a transitions with epsilon moves. This one is epsilon moves. So this is called as NFA with epsilon moves. The first step is to find out the epsilon closure of each state. Now what is meant by epsilon closure? Epsilon closures of a given state, suppose state A, means a set of state which can be reached from the state A with only epsilon moves including the state, suppose A itself. Now state, if I want to find out the epsilon closure of state Q0, then it is Q0, Q1 and Q2. So first step is when we conversion from NFA with epsilon moves to DFA, the first state we will find the epsilon closure of each state. Now to obtain the epsilon closure of each state, find out the epsilon closure of each state. Epsilon closure of state Q0 which is equal to Q0, Q1 and Q2. Okay. So the next one is epsilon closure state Q1. Epsilon closure of state Q1, there is no transitions from Q1, there is no transitions with epsilon moves. So it is Q1 itself. Second one is epsilon closure of state Q2 which is equals to, again there is no transitions with epsilon, so it is Q2 itself. Now the epsilon closure of state Q3, again it is Q3 itself, and the epsilon closure of state Q4, it is Q4 itself. Okay, this one is the first state to find the epsilon closure of each state. So it is epsilon closure of Q0 is Q0, Q1 and Q2. Now the next state, let epsilon closure of state Q0 which is equals to Q0, Q1 and Q2, consider it as a state A. Consider this state as a state A. Okay. Hence, we find out the extended transition functions, that is this A with input 0 which is equals to epsilon closure of del of that state, that is state A. A means Q0, Q1 and Q2 with input 0. Okay. So it is which is equals to epsilon closure take the union of this, that is del Q0 with input 0 union transition of Q1 with input 0 union transition of Q2 with input 0. So which is equals to epsilon closure. Now Q0 with input 0, there is a dash phi union Q1 with input 0, again Q1 with input 0, it goes to Q3. Then union Q2 with input 0, Q2 with input 0, again there is a phi. So which is equals to epsilon closure of Q3. Now the epsilon closure of Q3 is Q3. So we get a new state which is Q3. Let's suppose this state be B. Okay. Call its state as B. So call it new state. Okay. Now the next one, again find the extended transition function of A with input 1 which is equals to epsilon closure of the state A, that is Q0, Q1 and Q2 with input 1, which is equals to epsilon closure of del of Q0 with input 1 union transition of Q1 with input 1 union transition of Q2 with input 1. Okay, so which is equals to closure of Q0 with input 1. Again, Q0 with input 1, there is a phi, there is no transition. Q0 with input 1, there is no transitions. With Q1 with input 1. Q1 with input 1, again there is phi union. Q2 with input 1. Q2 with input 1, it goes to Q3. So this one is Q3. So epsilon closure of state Q3, which is equals to, when we find epsilon closure of Q3 is, this one is Q3. So it is Q3. So we didn't get a new state. So it is the state which we call it as a state B. Okay. Now, the next one is, again we find the extended transitions with the new state, that is B. So it is del dash of B with input 0, which is equals to epsilon closure B means Q3 with input 0. So which is equals to epsilon closure Q3 with input 0. Q3 with input 0, it is 5. So we get a 5. Next one, we find the extended transition function of B with input 1, which is equals to epsilon closure del of Q3 with input 1. So which is equals to epsilon closure Q3 with input 1, it goes to Q4. So it is Q4. Now the epsilon closure of Q4. We find the epsilon closure of Q4, which is Q4 itself. So which is equals to Q4. Okay. Q4, now this call it as a next state. Call its next state. Call it as a state C. Okay. Then next we find the extended transition function C with input 0, which is equals to epsilon closure of C means Q4 with input 0. So which is equals to epsilon closure of Q4 with input 0. So Q4 with input 0, it is 5. So we get this 5. Next one is, again find the extended transition function C with input 1. It is epsilon closure of del of Q4 with input 1, which is equals to epsilon closure of Q4 with input 0, it is 5. So we get a 5. So we didn't get a new state now. Okay. So the find the DFA. So first find the transition from its table for the DFA, which is state input 0 and 1. Okay. So states are A, B and C. Okay. So C is your final state and initial state is A. A with input 0. So A with input 0, it goes to the next state, that is called as B. So Q0, A with input 0, it goes to B. So here it is goes to B. A with input 1, A with input 1, this one, A with input 1, it goes to again B. So it is B. Then B with input 0, it goes to 5. Then B with input 1, it goes to through O. That is called as C. C. C with input 0 and 1, it is 5 and it is 5. Now the transition diagram for this DFA is DFA. It is state A and state B. So input 0, it goes to the next state, that is B. And A with input 1, it goes to the next state, that is. Now B with input, this one is C. B with input 1, it goes to B. With input 1, it goes to C. So input 1, it goes to C. And C is the final step. So this one is the conversion of NFA with epsilon moves to DFA without epsilon moves.